Um, Noel, you ready? Yeah, there you are.
Yep, I'm just pulling up my presentation. Can everyone hear me? All right. Hi, everybody. My name is Noel Geiger. I'm a senior physics major at Concordia College. And this year I presented, I'm just not. Okay. This year I worked on the Gleam Lunar Challenge at Concordia. We had a team for the Intercollegiate Gleam Lunar Challenge, and that's what I'll be talking about today. So what is Gleam? Gleam stands for Great Lunar Exploration for All Minnesota. It's a variation of GLEE. Instead of for the nation, it's for just Minnesota. This challenge was based off of a class that James Slatton did here at the U, where several groups would construct a quote Gleam PCP board. So a PCP board designed for this class by their TA that had a battery, several different sensors, an XB radio, and a TNC all on it. And they would connect those boards via XB radio communication. And in their exploration, they would, without being able to see their boards would be set throughout a room. And using the data they collected from those boards and the network of communication, they would try and figure out where their boards were in the room and what was happening around their boards. Different drops of like balls, flashing lights, different things like that. The Intercollegiate Gleam Lunar Rover Challenge was a lot more vague and a lot more free to do what we wanted to do for the project. The goal was to design a rover to explore a simulated lunar surface. And in that surface, when we were exploring it, we had to use our data that we collected from that to try and map the surface, the environment, and describe the lunar surface to the best of our capability. That was really all we were given. We were given some hardware. We were given 2 Gleam boards. One was constructed by the class and was given to us, and the other was just all the parts for it and the design. So if we wanted to make another one, we could. There was 3 extra XB radios, 4 including the one on the Gleam board that was given to us, an RC tank that could serve as a chassis for our rover, $250, many other useful parts, and the code written for the Gleam boards and that network of communication. We were told a little something about the lunar surface, an area roughly of 15 by 10 feet. It was supposed to be fully dark to the best capability of an indoor area. And it was supposed to have a cave, a ramp with a maximum of 32 degrees up. And at the top of that ramp, there would be a plateau, which would have stuff on it. And in the past, they gave us little hints about what could be in this lunar environment. They said that they put ice in there, they put flashy surfaces, magnets, rocks, different things like that. And that was really all that we were given. It was very vague, it was very mysterious, but that was part of the fun. We were given only a few restrictions. The rover must have a network of communication between the rover, a central unit is what we called it, but it was acting as a simulated lunar lander that would be on the lunar surface, and a connection to Earth. So one of our laptops outside of the room that we were exploring in. The total weight must be under 400 grams. That means the rover and the central unit combined had to be under 400 grams. Or if you wanted to, you could get signatures and financial support from different interested parties. And that was a fun little bit that was supposed to simulate like an actual team or a team of scientists that wanted to buy weight on a rocket. They had to get support, they had to get financial support so they could pay for the weight, the extra weight that they wanted on the rocket. And then came the fun part. Each team got to decide what we wanted to do for the design of the rover and what we wanted the rover to do. We decided between whether we would have 1 or 2 rovers, or some people even thought of 3 and just make them all very small. Would the central unit be on the rover, or would it work better just on the surface? Would there be any difficulty communicating with that central unit? How best could we map the environment? How would we want to do that? How could we do that accurately? What sensors should be on the rover? What do we want to pick up in that environment? What do we want to see? Should the rover have wheels or treads? And should we buy a rover, use the tank that was given to us, or build our own in some fashion? And my team had a lot of fun. We really did. And what we decided was the coolest thing that we could contribute to this was we were going to map the environment using a 3D point cloud and using the open 3D libraries to create a 3D map of the environment. To do this, we needed a LiDAR camera for mapping. We used the Terra B 80x60 LiDAR camera. And we thought of this idea because one of our teammates had already thought about trying to do this mapping thing. He had seen like a YouTube video and we were all like, yes, let's do it. And so we tried to design the rover sort of around that. We built a turret to have that 3D camera on, and we tried to get a 360-degree turn, but we didn't have the weight flexibility, so we had to settle for a 180-degree turn. And we had to program around that. We custom built the chassis, the body of our rover, using 3D printing, which I was the lead designer on that, and I had never done 3D printing before, but it was a lot of fun. And we operated our rover via a Raspberry Pi 4, and we had an IMU, a magnetometer, and then the LiDAR camera, a thermal camera, and streaming camera. And we decided on wheels, just for the versatility and traction. So what we learned a lot during this. And I gotta say, a lot of it was within the last 4 weeks, as you do. But that was one of the things we learned. We learned to not backload the work because design is very difficult and has a lot of different hiccups that happen along the way, especially within the last couple weeks. I'm sure a lot of you might know that. We learned how to effectively do team management and distribution of work, or we are starting to learn how to effectively do that. We learned how an XB radio and its communication actually work. We learned how to create 3D point clouds, and skills we learned along the way that are pretty simple, but I haven't done most of these before. Soldering, data processing, 3D printing, and a lot of different types of programming. I had never touched Arduino before this, but we used an Arduino Nano to control our microcontroller, which controlled our motors. And we learned so much more. This is what the Gleam challenge was for my team. It was exciting. It was super fun and engaging. It was frustrating as hell. It was creative. It was very difficult. It was fun and it was stressful. Overall, I think it was rewarding. We learned a ton and we had freedom to do what we wanted, which no other class had really given us before. To take a design into our own hands and decide as a team what we should do for it. If you are interested in, I'll get questions in a second. If you're interested in doing the Gleam challenge, I highly recommend it. They change it up every year. This year it was a lunar rover. I know a few years back, right before COVID, they did a quadcopter challenge for Mars. So it's a really fun thing, and you should look at the Minnesota Space Grant website if you're interested in joining one of these challenges. Any questions?
I have two for you.
Sure.
One, did you have to make any considerations? Did they have you look at environmental considerations like temperature or anything like that?
So not full on like what if the rover froze type of thing. We didn't worry too much about that, but we did have to say what could actually work on the surface of the moon, which there was funny moments where we realized, oh, we can't measure air temperature. Like, oh, shoot, we have to throw out that sensor essentially, and stuff like that. But what's your other one?
The other question was, have you considered possibly doing something like L-Space? It's a program that has you writing about a 250-page PDR to design an entire rover.
Oh, no, I haven't. But I mean, we did do a little mini PDR and stuff like that, but that sounds a lot of fun, like a lot of fun.
Talk to me afterwards.
Okay, I will. Yeah, this was a very exciting project, and it definitely made me interested in what I think I want to do for a career and stuff like that. But yeah, any other questions?
Could you elaborate on the XB radio communications? What that involves?
Sure.
Is that a short? I mean, is that a short distance thing, or
It's
anyway?
pretty short, I'd say. We didn't test the full capability. We were mainly focused on would it work from like 20, 25 feet away? Yes, good. There was a lot of problems with how to connect the XB radios and how to get that network of communication going where we could safely stream over that without using too much data. And it was very difficult. And I think they weren't meant for a ton of like data to be streamed at one time. But we were able to stream all the data from sensors using 2 XBs on the central unit, one that would receive the data and one that was connected to it that would send the data to the Earth module, the Earth XB. And that's how our network of communication went. That's how we did it, but yeah. Any other questions?
Is the goal to make it to the top of the plateau or to
The
map
goal,
it?
the goal was to map and describe the environment as best as possible. So
Is there a time limit for the
So,
mission?
yes, that was a fun part, thank you. We had as much time as we could power the rover. So our team tried to do it as long, and we stopped when our wheels stopped working because our microcontroller had run out of battery. And that was one of the things about the design, was how much battery power and how much battery weight can you afford to put on your rover to guarantee you had enough time to get around to the entire thing, to make sure you could do everything you wanted to do, see everything you want to see. But yeah.
Which
Can I throw in
battery?
Sorry, can I throw in one quick question before we move to the next talk? Can you backtrack to the photo of your rover?
Sure, yeah, and I will show off my rover at the exhibit later, but I'll do that right there.
I was curious how big, which piece of that is the LiDAR unit? You're using like a LiDAR thing that is made for phones or something?
No,
Or auto?
you
Yeah.
see that big black camera on the front? That is the LiDAR. It is quite a hefty little beast.
Okay, okay.
Yeah,
Yeah,
our rover came out. Our rover came out to be a monster of wires and cables. But you know, zip ties and tape made it work. So why not use that?
yeah. My Earth science colleagues have used LiDAR for decades, and the miniaturization of it is they can put it on drones now and things like that, which is allows them to innovate around
Yeah, we
around
use
what they used to do.
right. We use the Terabee line of products, and they had a really sophisticated LiDAR camera that gave us 4,800 pixels. So it was very easy to create a 3D point cloud from that without having to operate a turret that would go in more than 1 degree of freedom.
Okay. So it's time to move on to the next talk. Thank you very much. Bjorn and Aiden, I think, are next.